I finally found my dream function. Now, okay, now why do I call this infinite series as my dream function, right? The thing is, like, I have always seen this infinite series, like 1 through 1 plus x to the power n, it was sum from k equals to 0 to n, and then there's this, like, binomial, or let's say, combination storm, and then there's this x to the power k, right? So now, when I saw this, I always wonder, like, if there's also an expression where there's also this factorial over here, like just below the x to the power k, right? Because in that case, like this Taylor series will mean that some function exactly had this binomial term, or let's say, this combination term as their like derivative at 0, x equals to 0, right? That is super cool. And like today, yeah, I finally found this one, right? And the function is this is actually Laguerre function. It's U I R R E. Also like Laguerre polynomial, yeah, right. And it's defined for different n's, right. And yeah, and I finally found this function today, and it exactly is the way I want it to be, and that is super cool, right? And notice that there's some difference. Over here in the given like image, I have this going from k equals to 0 to infinity, right? But that's actually same, and the reason is because like n sub n plus 1, this is just 0, right? N sub n plus 2 is just 0, right? So for any k bigger than n, that's just 0. Tom, it's just 0, so that's actually the same thing. I just wrote this so as to make it more beautiful. Yeah. Okay. Now let's actually prove that this Laguerre polynomial evaluated minus x is actually equal to this series, right? So we have to go by the definition of Laguerre polynomial first. It can be defined in two ways, right? Like some people prefer to define it as like solution of a second order linear ODE, right? You can also define this as like Laguerre polynomial as the solution of this differential equation xy double prime plus 1 minus xy prime plus ny is equals to 0. Or the more convenient one, the definition is using the Rodriguez type formula, right? The Rodriguez formula. The Rodriguez formula is basically the formula involving nth derivative. Yeah, if we use this formula, the definition is actually that this Laguerre polynomial is e to the power x by n factorial, and then the nth derivative, right, of x to the power n e to the power minus x, right? Okay, so we're gonna basically use this Rodriguez type definition of the Laguerre polynomial to prove this interesting fact, right? Okay, so how do we go ahead? So first of all, okay, so we basically have a product and we need the nth derivative of that product, right? So there's a nth like derivative of product formula, which basically states that, let's say if I have to take nth derivative of the product of f of x, g of x, the formula is sum from k equals to 0 to n of this combination term mck, and then like the kth derivative of f of x and n minus kth derivative of g of x, right? We're gonna use this thing. So here it will be sum from k equals to 0 to n and ck, kth derivative of x to the power n minus kth derivative of e to the power minus x, right? After this, let's actually evaluate those terms. Now, if I actually take the kth derivative of x to the power n, I'm gonna get n minus 1 up to n minus k plus 1, and then x to the power n minus k, right? And in the other case, for e to the power minus x, it will be e to the power minus x times minus 1 to the power n minus k, right? So you can actually observe this pattern by finding, let's say, second and third and fourth derivative, and then you will notice this thing. After this, I'm gonna write those in a bit nicer way. So first of all, I can take this e to the power x and n factorial inside, right? So I can actually write 1 by n factorial as it is, and over here, this e to the power x and e to the power minus x will cancel each other out actually, right? So that's just same as being cancelled. And now this n minus 1 up to n minus k plus 1 can be written as n factorial by n minus k factorial, right? We have x to the power n minus k minus 1 to the power n minus k. So this Laguerre polynomial is now sum from k equals to 0 to infinity of n c k, and then this one becomes just 1 by n minus k factorial, and then this is minus x to the power n minus k, right? Okay, so now I'm again gonna use another property of sum. Like let's say if I have sum from a to b of f of k, this is same as sum from a to b, k equals to a to b of f of a plus b minus k, right? So if I'm using that over here, I don't know why do I just write infinity instead of n? Like it was just going fine, and then okay. So this one, I can now write it as sum from k equals 0 to infinity. So, sorry, 0 to n. Instead of k, I can actually write n plus 0 minus k, which is n minus k, right? So this becomes n minus k. And now if you substitute k as n minus k over here, this will just be k factorial. And then this is just k, right? Because if you input k as n minus k, that will be n minus n plus k, so just k. And now using the property of combinations, we know that n choose n minus k, it's same as n choose k, right? This is same as n choose k, and then minus x to the power k by k factorial. Now if you change x to minus x, we will have this Laguerre polynomial of minus x being sum from k equals to 0 to n of n c k x to the power k by k factorial. And my guys, so that completes the derivation. So there's actually this formula, right? There's actually this function which is a solution of this differential equation, and whose derivative at x equals to 0 is exactly this binomial term, or like this combination term. And that's super cool. Yeah. Okay, so I hope you enjoyed this. Just to recap, I showed why this is beautiful, and then we used this Roddick's type definition, and then we used this formula for nth derivative of a product, and then what we did was just to use this property of a sum, and then that gave us the answer. So that was it, guys. Hope you enjoyed the video. Thanks for watching, and I look forward to seeing you in the upcoming video.